All right, let's dive right into this. Welcome to today's explainer. I am absolutely thrilled you're here because we're going to explore what is honestly one of the most incredible, complex, and just flat out fascinating pieces of engineering on the entire planet. And you know what? I'm talking about a machine that's way more advanced than any computer, robot, or spaceship we've ever built. I'm talking about your own human body. Today, we're going to focus specifically on the amazing structural frame and the powerful engine that keeps you moving every single day.
So I want you to start by just asking yourself this question. How do you run, wave to a friend, and chew on your favorite snack all at exactly the same time? Have you ever actually stopped to think about that? It feels totally effortless, right? But beneath the surface, there is an astonishing amount of coordination happening. Your body doesn't just have one giant, clunky motor doing all this heavy lifting. Instead, it relies on entirely different groups. Think of them as teams, working together in absolute perfect harmony to get things done.
And this perfectly highlights a core concept we talk about in science, which is interdependence. Basically, your body is a super smart machine built with specialized interconnected systems. In science, interdependence just means that different parts completely rely on each other to survive and function. You literally cannot have one without the other. Now, while your body has a bunch of teams, like the circulatory system pumping your blood or the respiratory system handling your breathing, today our explainer is going to focus on the two main teams that make up your machine's physical frame and its engine.
Section 1. The skeletal system's frame.
Okay, imagine for a second trying to build a really tall, sturdy house, but you don't use any wood beams or steel or bricks to hold it up. What would happen? Well, if you just threw up the roof and the walls, it would instantly collapse into a giant puddle of fabric and shingles on the floor. Without your skeletal system, you'd basically be a puddle too. This system is the essential frame of your body. And check out that number, 206. That is the exact number of bones inside a fully grown adult human skeleton. But get this, here's a truly wild fact. When you were born, you actually had about 300 bones. So did you just lose 100 of them somewhere along the way? No way. As babies grow into kids and then adults, many of those smaller bones actually fuse or join together to form larger, stronger bones. And that leaves us with exactly 206.
Let's look at what these 206 bones are actually doing for us. Honestly, they are your ultimate armor. First and foremost, they provide support and shape, giving your body its structure so you can stand tall against the pull of gravity. But beyond just holding you upright, they act as a built-in security system for your most delicate soft organs. Think about your skull. It's essentially a permanent, ultra-tough bicycle helmet designed specifically to protect your brain. And your ribcage? It acts exactly like a knight's shield, wrapping right around your chest to guard your heart and your lungs from any kind of impact.
Section 2. Inside your living bones.
Now, we need to bust a massive myth right here, right now. When most people think of bones, especially, around Halloween, they picture these dry, white, dead rocks. But that couldn't be further from the truth. Your bones are living, breathing organs. Inside, they are buzzing with life. They're made up of elastic connective tissue and packed with essential minerals, mostly calcium and phosphorus. And that's exactly what makes them so incredibly hard. If we were to slice a bone open and look inside, we'd see two very distinct layers. On the outside, we have compact bone. This is that hard, dense outer shell that gives the bone its strength and smooth look. But right beneath that is something called spongy bone. It's called spongy because it's full of tiny holes, kind of like a honeycomb. But don't let the name fool you. It is incredibly strong, but all those little holes keep your skeleton lightweight. Actually, if your bones were solid, compact bone all the way through, your skeleton would be so incredibly heavy you'd barely even be able to move. And nestled right inside those tiny little spaces of the spongy bone is something absolutely magical. It's called bone marrow. And this totally redefines what our skeletal system does. Marrow is a soft, kind of jelly-like tissue, and it comes in two types. Red marrow is literally a factory constantly producing the red blood cells your body desperately needs to carry oxygen. And then yellow marrow acts as an energy reserve, storing fat. So your bones aren't just holding you up, they are actively working on the inside every single day to keep you alive and energized.
Section 3. Joints, bending, and moving.
But hey, a solid frame is only half the story, right? If our bones were just fused together in one continuous piece, we'd be stiff as statues. Before we look at how joints move, do me a favor. Take a finger and bend the top tip of your ear, or give the tip of your nose a little wiggle. You feel that flexible material? That's cartilage. It's a connective tissue that's softer than bone. Cartilage sits right at the ends of your bones to cushion them.
That way, when your joints move, your hard bones don't painfully scrape and grind against each other. Joints are simply the places where two bones meet, and they're held tightly together by strong elastic bands called ligaments. And we actually have several types of movable joints to allow for all sorts of actions. Hinge joints, like your elbows and knees, well, they swing back and forth just like a door on a hinge. Ball and socket joints, you'll find those in your shoulders and hips. They give you an amazing range of motion, letting you swing your arms in big circles. Gliding joints in your wrists allow tiny bones to slide smoothly over one another for delicate little movements. And the pivot joint in your neck, that's what lets you swivel your head from side to side to look around.
Section 4. Muscles, the power to move.
Okay, so we've got this fully articulated, protected, and well-cushioned frame. But a frame can't move itself. Just like a car chassis needs a motor, our body needs one too. So let's talk about our body's engine, the muscular system. Muscles are these stretchy, almost rubber band-like tissues attached to your frame, and they provide the actual physical power to move. And listen, if you thought 206 bones was an impressive number, get ready for this one. There are over 600 muscles in the human body. That's right, over 600 individual muscles are responsible for literally every single movement you make. We're talking everything from the explosive power you need for a full-speed sprint, all the way down to those quiet, totally invisible muscle contractions that allow you to take a breath of air while you're fast asleep.
But here's the catch. Not all of those 600 muscles take orders from you directly. We actually divide them into two different categories. First up, voluntary muscles. These are the ones you consciously control. For example, when you decide to smile at a friend, it takes about 13 voluntary muscles in your face working together to make that happen. On the flip side, we have involuntary muscles. Now these are the unsung heroes working entirely on autopilot. You don't have to consciously think about making your heart beat or, telling your stomach to digest that snack you just ate. Your super smart machine just handles those involuntary muscles automatically.
Section 5. Teamwork, pulling in pairs. So how do these voluntary muscles actually move our skeletal frame? Well, it all comes down to some brilliant mechanics and incredible teamwork. Your skeletal muscles are securely fastened to your bones by thick, super strong cords called tendons. When a muscle wants to move a bone, it gets a signal from your brain and it gets shorter and tighter. We call this contracting. But here is the absolute golden rule of the muscular system, and it is absolutely crucial you remember this. Muscles only pull, they never push. Because a muscle tissue can only tighten and pull inward, it physically cannot push a bone away from it. And because of this one specific limitation, our muscles must always work together like best friends. They have to pull in pairs to get any job done.
Let's actually see this pairing in action with a super simple movement, just bending your arm. Step 1. To bend your arm up towards your shoulder, the muscle on the front of your arm, the bicep, contracts. It acts as what we call a flexor, pulling the bones of your forearm up. But remember that golden rule. The bicep can't push the arm back down. So for step 2, the muscle on the back of your arm, the tricep, takes over. It acts as an extensor. The tricep contracts and pulls in the exact opposite direction to straighten the arm back out while the bicep relaxes. Pull and pull. Flexor and extensor. Honestly, it is a perfect mechanical dance.
So what does this all mean for you? Well, now that you know how perfectly these systems are designed, it becomes super clear why your daily choices actually matter. Keeping your machine strong is entirely up to you. Eating a balanced diet that's rich in calcium, things like milk and cheese, directly deposits those hardening minerals into your living bones, and that helps prevent a weakening condition later in life known as osteoporosis. Exercising regularly literally forces your muscle cells to grow wider and thicker, which makes your engine way more powerful. And simply taking 5 minutes to stretch and warm up before playing sports makes your joints and ligaments nice and flexible. That alone prevents painful injuries like sprains, bone fractures, or even joint dislocations.
We've seen how the skeletal system provides this ultimate protective frame, and exactly how the muscular system acts as the dynamic engine pulling it all into motion. They are completely interdependent. So, I'm going to leave you with this final thought. Now that you know exactly how your frame and your engine work together in such perfect harmony, what amazing move will your super smart machine make next? The possibilities are entirely up to you. Keep moving, keep learning, and thank you so much for joining me for this explainer.